All right, over here, what I have pictured is the electromagnetic spectrum. These are basically the full spectrum of all the possibilities for light waves that can exist. You guys have probably dealt with this before. I'm always trying to look for something positive about this whole crisis thing, and I guess the most positive thing that I can think of with respect to this is that I don't have to listen to you guys sing that crappy song this year. So I thank God for that. Anyway, gamma rays. I'm sure you know the whole song. I'm not even going to go through it, right? But what we're going to do is we're going to focus right here on the visible part of the spectrum, and now it's enlarged right here because you've got basically all the colors that you would see in the rainbow: violet, blue, green, yellow, orange, red. And you know what? All different forms, right? It's a smooth transition from there to there. It's not like there's only 7 colors in the rainbow. There is a gazillion colors in the rainbow. And so basically, we want to talk a little bit about color and how that works. So if we think about what a light ray is, it's composed of basically packets of light. Light travels in packets. And what we want to do is we want to see how that works. So what we'll do is we'll focus on a specific color light here. There's the color red right there. Basically, I'm using an infrared thermometer to do that. Just basically, if you look here, there's a beam of red light that comes out of my thermometer here. And what this is doing is it's sending gazillions of red photons into this paper right here. They end up reflecting, and then the camera ends up picking it up. So the point that you really want to take home here is that light travels in packets. I've got a device, could be a lamp, could be a laser pointer, could be something, and it's emitting basically this whole beam of red light. If we could boil it down to the smallest possible unit of light, we would focus in on it, and what you would see are these photons. Now, these are not particles, but they do sometimes behave like particles. There are gazillions of these things that make up the beam. So it's just like when we take objects, the smallest, I would say, simplest form of an element is an atom. In this case, the simplest form of light will be the photon. And photons come in all different colors, if you will. Or, if we think back to chemistry, I think you learned a little bit about energy levels here. You've got a blue photon. You've got a red photon. You've got a green photon. And if you think about it, any of those colors within the visible spectrum, you have those photons as well. You even have things that you can't see, like infrared light and UV light and X-rays, radio waves, microwaves, all that stuff. So if we can think about how this translates into what we see, we have to think a little bit about how the human eye works. Basically, what the human eye is a detector. So I'm going to end up posting a PowerPoint online for you about color, and we don't really want to make this a biology lesson, but one of the detectors in your eyes are these things called cones, and you have basically, we call them different colored cones, and it's a little bit of a misnomer, but just to say, all right, we got 3 different kinds of cones. There's the red cone, green cone, blue cone. They can all pick up different forms of light. The blue cone can actually pick up anywhere from 400 nanometers to about 550 nanometers. And the reason we call it blue cone is because right about here, this wavelength is blue light. So the peak is at the blue light. The green cone can almost pick up every form of light, but it is most absorbent in the green section. And then red cone, it's actually in the reddish orange range here, but it can pick up anywhere from 500 to 700 nanometers. So these are the 3 detectors in your eyes that are able to detect something. And what they can do is they can project an image onto your brain, and you might see a certain color just based off of that. So in order to think about that, what we need to think about is maybe an object that's outside, and also what makes up light. So if we're thinking about light basically, usually we think about, something that appears white, and white light can be a little bit deceiving because white light is a mixture of all the colors of the rainbow. So basically, you have your red, you have your green, you have your blue. And this is all layered on top of one another. You got your violet. Is this orange? Is it? It says cherry. What does cherry look like? That's kind of orange, right? All this layered on top of one another is going to yield what appears to be white light. There's actually no such thing as the color white. It's just what's inside your head. It's going to appear white. If we shine that through a prism, basically you've seen these colors been separated out in any number of ways. A lot of times when it hits a window, you might see the colors start to disperse a little bit. If you put on 3D glasses, this happens. And all that, if you look at the rainbow is actually a natural way of separating light out, and you can see that the colors make up the white light. This paper right now, it appears to be white. And what we're going to think about is how things get reflected here. So just think about our paper here, because this is something that we would claim is white. Right now, there are all kinds of photons in this room shining down on this light. And that's because there is a nice lamp above my head that is doing that shining. So let me turn it back on, shine the light in, and what's happening is it's emitting all colors of light here. It's emitting blue, red, green. It's all hitting the paper. And then our eyes are here. And they're detecting what's coming off the paper. And what comes off the paper is everything. This paper reflects all the light, every single color. So since every single color is hitting the paper, every single color is being reflected by the paper, and it's reaching your eye, and your eye says, hey, it's white. Now, you may notice that what I'm doing here is I make a spot right here where the paper is no longer white, it's red. What's happening here is that's all that light's still coming in here. You've got the green coming in, you've got the blue coming in, and you've got the red coming in. But now, these two get absorbed by the paper because the ink is actually an absorbing material, whereas the red is reflected. And here's your eyes doing the detecting. Your eyes detect this as red. I can do the same thing here. This paper's no longer white here, it's blue here. And it's still each and every single color coming in, shining down. However, in this case, this part of the paper now only reflects blue to your eyes, so you're going to detect it as blue. So this is one way that color is formed, and we want to think about another way color is formed as well. We'll do that in another video.